Hello, welcome to the second lesson on SPSS. So in our first lesson, we imported this data set. And after getting our data set into SPSS like this, the next important thing to do is to perform or run descriptive statistics in order to familiarize ourselves with the data with measures like the mean, the median, the standard deviation, the frequencies, and others. Another reason for performing descriptive statistics is to check for errors such as missing values or outliers and to correct them. The last major reason for performing descriptive statistics is to check whether certain assumptions in statistical tests are met. And one major assumption that runs through almost all statistical tests is normality. We want to find out whether our data, especially data on the numeric variables like age and height, we want to find whether these data sets follow the normal distribution curve. The normal distribution curve is very important in statistics, and it is a requirement to perform most of the inferential statistics or inferential analysis in SPSS like t-test, ANOVA, and others. So let me take some time to explain the normal distribution curve before we even come back to proceed with our descriptive statistics. So I have a shape of the normal distribution curve here. So this is the shape of the normal distribution curve. It is also called a symmetric distribution. Symmetric in the sense that it has two parts that looks exactly the same, one looking like a reflection of the other, and it has been divided by the mean at the center. So that is where I've marked with the blue line. So the mean will be at the center, and here the mean is the same as the median. So because it's at the center, it makes sense to say that it divides the data into two equal halves. Another thing about the normal distribution curve is that it has most of the data set clustered around the mean value at the center. So let me give an example to explain this better. Let's say we have the test scores of students in a particular class, and the mean or the average value is 50, which is the same as the median. What you notice is that most of the students will score very close to this average value. So let's say from a range of 40 to 60, you have most of the students having their test scores within the range of, let's say, from 40 to 60. But it is very uncommon to find, or mostly you find few people to the extremes. So let's take the extreme right for instance. And it's very uncommon to find people score or have test scores like 90 or 95. Mostly few people. And mostly have few people have test scores to the extreme left like 10 or 15. But it's very common or likely to find values like 40, 45, 43. Between the ranges of 40 to 60, most of the data values or most of the students will have their test scores within that range. The higher percentage will find their test scores within that range. That is why this normal distribution curve is a requirement to perform most of the inferential statistics in SPSS. And the reason is that most of the real-world data sets follow this normal distribution curve. Mostly when we take data on variables like height, test scores, IQ scores, and other variables, when we take data sets on these variables, they mostly follow the normal distribution curve, as I've used the test scores to explain. So I have another example here to explain it further. So I have information on the average height. Let's say this is the average height of Ghanaian men with a standard deviation of 6 centimeters. But that is what I've represented on this normal distribution curve. So the 170, which is the mean, is at the center. And what this normal distribution curve is saying is that, or it has been proven that within one standard deviation means you add this standard deviation to the mean value of 170 within one standard deviation. So you add it once to, so 6 plus 170, which is 176, one standard deviation to the right. Then we subtract it from the average value of 170 as well. So one standard deviation to the left will be 170 minus 6, which is 164. And it has been proven that with any data set we take, 68% of the data set will fall within one standard deviation above the mean. It could be a data set on any variable, but when we have the mean and we have the standard deviation, what this is trying to say is that 68% of the data set will fall between one standard deviation. And within two standard deviations, it's been proven that 95% of the data for the people we are talking about here, Ghanaian men, will have their height. 95% of them will have their height within two standard deviations. And what two standard deviation means is that we multiply this standard deviation by 2. So 6 times 2 is 12. When we add it to the 170, we get 182. And when we subtract it from the 170, we get 158. And what this means is that if the average height of Ghanaian men is 170, 95% of all Ghanaian men will have their height ranging from 158 to 182, which is a very big percentage and covers almost all of our data sets. it's left with only 5%, and that is called the empirical rule. So that is what the empirical rule says, that 68% of the data set or 68% of any data set fall within one standard deviation above the mean, 95% fall within 2 standard deviation about the mean, then 99.7%, almost all the data sets fall within 3 standard deviations. So that is that about the normal distribution curve. If you need more explanation, if you want to learn more about the normal distribution curve, you can search on it, read on it, or watch videos on it. So let's go back to SPSS to continue with our descriptive statistics. So I mentioned that one of the reasons why we perform descriptive statistics is to check whether certain assumptions are met, and one of the assumptions is normality. We want to find out whether our data follows the normal distribution curve. It's a requirement for most of the inferential statistics. That is why I went on to explain the normal distribution curve in detail. Now let's proceed with our descriptive statistics. So we have the right kind of descriptive statistics we perform for categorical variables, and the right type of descriptive statistics we perform for numeric variables as well. So let's start with the categorical variables or qualitative variables. So what are categorical variables? They are variables that are put into categories based on similar characteristics, like gender is a categorical variable, religious affiliation, income levels, educational levels, marital status, skin color, yes or no questions. All these are categorical variables. They are put into categories. And another thing about categorical variables is that they mostly have their responses to be in words. So if you ask of somebody's gender, the response you are going to get is either going to be male or female, which are all in words and not in numbers. Marital status, you are going to get single, married, or divorced, something like that, and they are all in words. So there's the right type of descriptive statistics that we perform for this kind of variables, and it's mostly the frequencies. So let's look at how to do that. Let's go through the steps. So the first step is to go to the analyze, click on analyze, go to descriptive statistics, go to frequencies. Frequencies is the best option we use for categorical variables. So here, the only categorical variable we have here is the gender. We remove the gender into this variable box by clicking on this arrow, and it's selected already. So we click on this arrow to move it to the variables box. Then we click on OK. So we have this frequency distribution table generated. But the first part here is statistics, telling us the number of valid responses in our data set. So our sample size is 20, and it is telling us that we have no missing value. So missing is equal to 0. So now let's come here. So we have the frequencies for both categories. In this variable gender, we have 2 categories, which are the male and the female. So from this table, we can see that the male were 9 and the female were 11. So if there is anything that we need to report about this categorical variable or any categorical variable in any kind of data set, it is going to be the frequencies or the count, the number of people that fall under each category, and probably their respective percentages. So let's see this one. So in our data set, we have a total sample size of 20, and out of these 20 people, 9 of them were males. So if you are going to report, what you say is that out of the 20 respondents, 9 of them were males, representing 45%. You can decide to put it in brackets. You will say that out of the 20 respondents, 9 into bracket 45% were males, and 11 into bracket 55% were females. So if there was anything we need to report about this categorical variable, this is how we are going to report it, and it's going to be the frequency and the percentage. So that is all we need. We could have performed this same kind of descriptive statistic for our numeric variables, but it will not really make sense, and mostly that is not what we need to report about our numeric variables. So let's try to generate this kind of statistics for the numeric variables and see how it will appear. So I'll go to analyze, descriptive statistics, frequencies. Let me add 2 numeric variables here. So age and height. Click on OK. So the first thing that appears is this one, statistics, summarizing all the 3 variables, telling us the number of valid and the number of missing. So the number of valid in each of these is 20, and it is telling us that there's no missing value in any of these variables. So if there was any missing in any of these variables, it would have been presented here, where we don't have any missing value in any of these variables. Then it picks them one after the other. So gender, so it generated just as the first one, And when we come to the numeric variable age, so that this table is a little longer, and it is because you have a lot of unique values. Although some appear 2 times, some appear, so this 46 appeared 4 times. So it is the mode for this particular variable. But mostly you don't need this, you don't need to report this about our numeric variables. Mostly we report things like measures of central tendency, like the mean, the median. Most of the time it's the average or the mean that we report about our numeric variables. That is why this kind of frequency distribution table telling us the frequencies and the percentage is not really important for numeric variable. Mostly what we need to report is the mean if the data follows the normal distribution curve. So for the height as well, we have similar table, but we don't need this. So let's look at how to perform the right type of descriptive statistics or descriptive analysis for our numeric variables. So we go to analyze descriptive statistics. We can use these same frequencies options, although it's not specifically for that, but we can still use it, make some adjustments, and use it to perform the right type of descriptive analysis for our numeric variables as well. So here we don't need the gender. I'm going to move it out. So now we have our 2 numeric variables in the variables field here. So here the adjustments or the settings I need to make is to uncheck. So here what I will do is that I will uncheck this display frequency tables. This is here because it's mostly for categorical variables. So I'll uncheck this one and I'll go and click on statistics here. And I'll go and select the measures of central tendency, which are measures for numeric variables. So I'll select the mean, the median, the mode. I don't need the sum. And I'll count the measures of dispersion side. Select the measures of dispersion or measures of spread I want. So the standard deviation, I want the standard deviation, I want the range. And we also select the minimum, maximum, and standard error of the mean. So we also have measures of distribution, measures of shape here. I'm not going to select any of these. So I've selected the measures I need for these numeric variables. I'll just click on continue, click on OK. And you see that this table has been generated summarizing the measures I chose for the 2 numeric variables, age and height. So we have the mean for age here, we have the standard error of the mean, we have the median, the mode, the standard deviation. But when I look at this standard deviation value, it's 74.893. It's even bigger than the mean value, and this suggests that there's a mistake. It indicates a possible mistake in my data set. But most times you don't need to have a standard deviation, a spread which is higher than the mean value. So I said one of the reasons why you perform descriptive statistics is to check for errors and correct them. And this suggests there is an error. Having a standard deviation bigger than the mean suggests there is an error. And even this maximum value of 376, meaning we have an age of 376 in the variable age. And I don't expect to have any age even above 100. So this is possibly a typing error. Let's say I wanted to type 37, then I type 376. So I can always look at my data to figure it out. Because this is a small data set, I can just go through and see where this extreme value or outlier is found. But let's say it's a very large data set and I have to use different approaches, but I'll be able to see the row number where this extreme value is found. Sometimes it can be more than one, so I will need an approach that will help me to figure them out easily. Not necessarily to scroll through everything, but to tell me the row numbers where I can find these outlier values. So let's go back to our output window. So when we look at the height, we have a summary of the measures we chose presented here for us. So you have the mean value, you have the standard error of the mean. But mostly what we report about the numeric variables is also the mean value, sometimes only the mean value. So you see that the mean height or the average height in our data set is 166 centimeters or something like that. Then we also report the average age that we have, because most of the times we are comparing the mean value to an established mean value and we draw conclusions. We are not doing inferential analysis now. When we get there, you understand it better. So now we've also looked at the right type of descriptive analysis we can perform for numeric variables, but the approach we used was not specifically for the numeric variables, just that we'll be able to use that to do it as well. So let's look at the right way to do the descriptive statistics for the numeric variables. So you go to analyze descriptive statistics, then you go to descriptives to analyze descriptive statistics, then you go to descriptives. So we select descriptives and you see that the categorical variable does not come here at all because this is specifically for the numeric variables. So I'll select the two together by clicking on the shift click on this arrow to bring them into the variables field. And what I'll do is to click on the options. Because it is for the numeric variables, some measures have been selected already. So you have the mean selected, you have the standard deviation selected, the minimum, maximum. If I don't want any of them, I can uncheck. I'm just going to leave them and add standard error of the mean, also add the range. I'm not going to add anything here. So these are okay for me. So I'll just click on continue, click on OK, and it has summarized the descriptive statistics for the measures I chose, just like this one. Just that this one has been presented in a horizontal format and this one was presented in a vertical format. When you go with this approach, it just presents it in horizontal format. That is the only difference, but we can select the same measures. So we have the range here 344. Here too, when you check, you can see that the range is 344 for the age. The standard deviation 74. And you can also find it here. The mean of 60.7, you can also find it here. So same thing has been presented here, just that the format is different. So now we've looked at how to perform the right type of descriptive statistics for both the categorical variables and the numeric variables. So the last thing I want us to look at in this lesson is how to visualize this kind of descriptive statistics. So we use graphs to visualize these descriptive statistics. So let's go through the steps. So you can follow similar steps we use to generate the tables. So we go to analyze, descriptive statistics, frequencies. You can use the same one again. I'm going to click on reset so that all the variables will move to the left. Now select the one I want. For the chart, we are starting with the categorical variable. So I'll move it into the variable field. So I'll move it into the variables field. Then here you want charts. So I'll click on the chart option here, and there's the right type of chart for categorical variables. And the most appropriate charts, or the two charts we can use for the categorical variables, are bar charts and pie charts. So let's start with the bar charts. I'll just select it, click on continue, click on OK. So you see that the table has been generated again, and it continues to generate the graph. So the same information on this table here is what has been presented here in a graphical format, or in the form of a chart, which is the bar chart. So we have the frequency for male here, which is 9. The same thing has been represented here. So in between 8 and 10 is 9. And the female were 11. So we can also see that here. And we can double click on this chart to edit it. So we can select these bars, click on this one to change the color to any color you want. We can double click on this again, come here to change the colors here. So I can select only this one and change the color of only this one here. Click on up. So you see I've been able to edit that. I could have even changed the background color and all those things, but these are not really important. So if you have a chart like this, you can copy and paste it in Word in your research work. So what you do is just to right click on copy, go open your Word. If you want to insert it in any part of your Word document, you can do that. So I'm going to paste it here. I can also resize it, or I can resize it and place it anywhere I want. So you can copy and paste it in your Word. Let's also look at how to generate the pie charts. Also for the categorical variables, so you go to analyze, descriptive statistics, frequencies. The gender is already selected. Click on charts. This time I'll choose pie chart. It's also appropriate for categorical variables since we mostly have few categories. So I'll just click on OK, because you see it's only 2 categories. Now let's look at how to visualize the numeric variable as well. We can follow same steps, analyze, descriptive statistics, frequencies. Let's move this one out, move our numeric variables into the variables field, click on chart, and the right chart for these numeric variables is the histogram. So I mentioned that another reason why you perform descriptive statistics is to check whether assumptions are met, and by selecting this one you can check the assumption of normality. So you check this box to show the normal distribution curve on our histogram. I'll click on continue. Now I don't want the frequency tables to be generated. I don't want those lengthy frequency tables to be generated. So I'll just uncheck. I want to see only the charts with a normal curve on it. So I'll just click on OK. And you see that these histograms have been generated. This one is not normally distributed because we earlier found an extreme value. We found an age of 376 or something, and that has skewed our data to the right, making it not normally distributed. So when you see a curve like this, when you visualize your numeric variable with a histogram and you see this kind of curve, it doesn't follow the normal distribution curve. But let's look at the next variable, height. You see that you can see this bell-shaped curve, meaning that this one follows the normal distribution curve. So let's go and correct that extreme value and see if the A2 will follow the normal distribution curve, because if it doesn't follow the normal distribution curve, we cannot proceed to do any inferential statistics for this one. So let's go back to the data view, delete this one and type 37. But I think that is what I wanted to type. Click on enter. Now let's generate the chart again and see if the age follows the normal distribution curve. So descriptive statistics, frequencies, that's already been selected. This one is click continue, click on OK. So now this is the age. You can see that when I did that correction, it now shows the normal distribution curve, meaning that this age follows the normal distribution curve, and we can proceed to do any inferential kind of analysis with it. The height too, it follows the normal distribution curve. So that is that. The graphs option here can also be used to generate this chart. So let's look at how to do that as well. Let's look at how to use this graphs option to generate same chart we generated. So go to graphs. We are starting with a categorical variable. Go to graphs, choose chart builder. Bar is already selected here. Then double click on the first one, simple bar. Double click on it to select it. Then you move your categorical variable here, gender, into the x-axis, and you click on OK. And you see that the same bar chart we generated using the frequencies option has been generated here without any table, without any frequency table. So the graphs option generates only the graph without any table. So this one too, you can double click to edit it any way we want it. Now let's look at how to generate the histogram for the numeric variable as well. So go to graphs. This time go to legacy dialogs, choose histogram because that is what we want. Then move our numeric variable into the variable field. Okay, so I think here you can do it one at a time. So I've selected the age. I'll just check display normal curve to show the normal curve on it when it is generated, and I'll click on OK. So now you have this one is for the variable age. So it is normally distributed now as I made that correction. So you can generate for the height as well. So I'm going to end here. Now next lesson we look at data cleaning and data transformation in SPSS. So thank you very much for watching this video as well. See you in the next lesson.